Hello, I'm Roger with CoderEU, and in this video we're going to be discussing using polyfills and transpilers in JavaScript. So let's dive right in. Polyfills. So what are polyfills? Polyfills are snippets of code that help implement modern methods in older browsers. Why would I want to use polyfills? So ECMA script 6 or ES6 and ECMA script 7 or ES7 introduced a variable of new methods in 2015 and 2016 respectively. So older browsers like Internet Explorer 11 do not support them. So methods that were introduced are like array prototype includes, array prototype find, along with find index, fetch, maps, and promises. So what libraries are there for polyfills? Core.js is going to be the first. It's probably going to be one of the bigger communities. It has a pretty substantial following. And it is actually used as part of Babel.js, which we'll discuss later. So Core.js is kind of, you can install this from the npm repository if you're using Node, but it allows you to be able to import the specific features that you're using in your JavaScript, or you can just include the entire Core.js file, everything. However, I don't really suggest that because, if you're importing a lot of functionality you're not really using, it can really impact your performance. So next up, we have polyfill.io, which is an easy-to-use site that creates custom polyfill scripts based on the UI's requirements and available browser features to reduce the library size and increase load speed. So over here, here's Polyfill.io. You can go to create a polyfill bundle. You can basically select all the features you want or that your application uses. They have a wide variety, if you use fetch or if you do internationalization. There's support for that kind of work as well. As you see here, there's the variety of languages that you can include. And then what will happen is it'll generate you a little URL up at the top, which what you will do is you'll just take that URL and put it into the header of your HTML page, the header or at the bottom of your body, and it'll basically load this JavaScript file. And so, for example, what's nice about this though is that if I were to load this file in Chrome, most of this functionality, like for example, the ES6, ES7 features are already implemented in Chrome. So whenever I go to hit this JS file, it's actually not going to generate a JS file with that functionality in it since my browser already has it. So like if I were to load this in IE11, that functionality doesn't exist. So it will include those functionality in the file that it sends over. So things to think about when using polyfills. As I kind of spoke to earlier, only include the polyfills you need to run your code because including too much can slow down page loads. Which include, like for example, if you were to include internationalization for numbers and dates and you just decide to include every language in a library, the minified library could exceed 150 kilobytes or maybe even upwards to half a meg if it's uncompressed. If the polyfills you're looking for is not available in Core.js or in Polyfill.io, you can try looking for it in the npm repository or just through Google searches or any other search engine that you might choose. So let's jump into an example that I have over here where I wrote a script that basically uses includes. Now over here under resources, I'm actually using the Polyfill.io URL to basically pull in a polyfill with includes in it. Now, when I ran this, as you can see over here in the window, it said it found includes. Now let's jump over to Internet Explorer 11 and we'll take a look. And as you can see, it says here that it found the includes function as well. So like we can just refresh that real quick. Okay, now we go back over to here. What I can do is say, let's remove this reference to the polyfill library. Okay, we'll go ahead and save it. And then I'll go back to IE. Jump to it. And as you can see, it showed that it did not find the includes method. It errored out because it didn't exist. But if we go back to the base JS Fiddle, you'll see that it did find it. So now let's go back to our PowerPoint. Next up, transpilers. So what are transpilers? Transpilers are libraries that convert JavaScript code from a modern syntax to a style that older browsers can understand. Transpiled code is not always that easy to read. So for example, as an example, here is Babel.io, which is one of the main libraries that we'll be discussing. And here's a class that was written using ES6. Okay, so now if we go over here and kind of change the file a little bit, it'll go ahead and render the output of this. And as you can see, this is basically an IE11 compliant JavaScript file. It's not as pretty as the ES6 version of this code. So, but older browsers can support reading this style of code then at that point. So why would I want to transpile code? So starting from ES6, some of the following syntax changes were introduced. There were arrow functions were added, async await functions, classes and inheritance, deconstructor assignments, spread operators, and template literals. So let's jump to an example over here where I've written a script file where I defined a class, and then I've used I've used template literals right here, and then I basically replace the contents of this div with the output of loop 1, loop 2, loop 3, and a small message. Okay, so now when you run that, you'll see it ran successfully. Now jumping over to IE11, you see that I already have that here. Like I have the page loaded up, and it ran the script, and it was actually able to interpret ES6 by transcoding the script that I wrote into something it can understand. So what libraries are there for transpiling? So Babel.js is more or less the de facto standard in the industry for handling transpiling code that leverages core.js as its standard library for polyfills. The library can be configured to transpile code to target various platforms and is flexible enough when coupled with a module bundler like Webpack to handle a wide variety of scenarios. So let's go ahead and we're going to jump to an example. So just as a reminder, all links that I'm using in this video will be in the description below. And I will also be putting up a GitLab repository with the sample example or the sample project here that'll kind of show you so you can kind of pick it apart. So I basically started off with a Webpack starter, Babel Webpack starter project that was done by Traversy Media, by Brad Traversy. So he had a pretty good minimalistic implementation of Babel with Webpack, which basically you can kind of see here, where we're setting the preset env, which handles a lot of the, and here's the we're ingesting the Babel polyfill. So Babel provides a polyfill library, but they're migrating users over to using core.js. So this library itself really is just a pointer to the node core.js library. Now I had to make a little bit of changes in this one in order to support IE11, primarily because fetch is not included in core.js. And there's some debate over that. There's actually a thread on the GitHub page that you can take a look at. And basically what they're saying, or what they said, was that fetch isn't implemented as a standard across a lot of the browsers. They're kind of, some of them support it, some of them don't. So since some of them don't support it, they just weren't going to include it outright. But you can include or install a package called whatwgfetch in your project, which can add that fetch polyfill to your project. So let's go ahead and take a look. Actually, let's go ahead and we'll build this. Well, we'll start it actually first so I can show you how it looks. So all this really does, going through the code, you see here, it's just going to retrieve this URL worth of data and spit it out to the screen along with the hello world. So if we come over here to the console, you can see here's our hello world. And here is the JSON that was retrieved from our call. Now if we take this over here and go to IE, and load this up. Let's open up the developer tools. Refresh our page so we can get you'll see, there you go. You have hello world, and here's all the objects from the URL that we retrieved. Now let's go back over here to Visual Studio Code. And what I'm going to do is kind of show you something here. Now, right now, basically what this does is the way this Webpack is configured, it kind of throws in the entire Babel polyfill library into the file that it generates, the JavaScript file. So if you go to npm run build, what's going to happen is it's going to compile your code into something that you can deploy. So under the build directory here, you'll see that there's an app bundle. Now, if you look right here, it says that this app bundle is 94.3 kilobytes big for something that is pretty small. Like this is really all the code we wrote, or that was written. But it added a lot of extra polyfill code to the bundle. So can we do better? I think we can. So let's switch over to another branch that I have where I've basically changed this little project to use Babel's use built-ins usage. So let me go ahead and install the necessary dependencies because I changed a few of them. And basically, just to kind of explain what I did is I removed the Babel polyfill library from this branch and I replaced it with core.js since it's basically the same thing anyways. And then in the webpack.config, I've removed the reference up at the top to include the entry point of the polyfill library and updated the preset env to use built-ins usage along with the reference to the version that I used for the library. There we go. Now it's installed. So now going to the app.js, you'll see I have here the same code. Now what if you do this on your own projects, what you probably need to know is if you're using async or awaits, you're going to need to install the regenerator runtime library with your code and make sure you import it. Okay, so let's go ahead and change this. We're going to comment that out, and this line right here will basically import the entire core.js stable polyfill library. So let's see what effect this has on our bundle size. So there you go. Now the bundle's built. 132 kilobytes, not in the right direction we were hoping for. But there is a way we can do that better. So like I mentioned earlier, only include the references to the libraries that you plan on using. So in this instance, Promise is the only extra polyfill we really need for IE11. So let's go ahead, save that, run build again, and let's see what happens. 38.6 kilobytes. That's a lot better. So from our original branch, the master branch was 94 kilobytes large. We've basically more than cut the build size in half. Now, let's see if we still if this still works. Now, obviously in Chrome, these are all features that come baked into the browser. So yes, it's going to work. Now let's switch to IE. Open a new tab. Open our page. Now let's take a look at the developer tools. Refresh our page here, and there you go. You have our hello world and the fetch for the data that we requested. So it did work. So now to wrap up, why use polyfills and transpilers with JavaScript? Writing code using newer standards like ES6 helps make it easier to organize and understand large projects compared to how it was before. Users with older browsers like Internet Explorer 11 do not support ES6 or newer. Microsoft Edge didn't support ES6 until Edge 14 was released in late 2016. StatCounter.com states that as of January 2020, 2 to 3% of the internet traffic from countries in North America and Europe still use Internet Explorer 11. How do I know if I should use polyfills or transpile code? Know your audience. So jumping over here, this is StatCounter.com. We can see here, this is the browser version market share for North America. 2.16% of traffic is still using IE11. In the United States by itself, 2.24% use IE11. In Canada, a little bit more with 2.81%. In Europe, 2.07%. In the United Kingdom, they kind of follow along Europe with 2.09%. And Germany uses 2.64%. So other useful websites that you can use is CanIUse.com that allows someone to look up methods and different types of syntax to see which browser supports what they're wanting to do. So if we jump over here, we have fetch shown up on CanIUse, and it shows you here IE11 cannot use fetch, and Opera Mini cannot either. If we were to search for, let's say, async functions, You'll see here, again, IE11 does not support async. Neither does Opera Mini. Another good example or another good site to look at is the Mozilla Developer Network, or MDN for short. It's a good source to find documentation and examples on methods and syntax along with what browsers support them. So here we have arrow functions that are being shown, which you can see they have plenty of examples and how the syntax is used. And then at the very bottom, you'll see how they have a chart for browser compatibility. Well, that's it for this video. If you found the information that I shared today useful, then feel free to like the video, subscribe, leave a comment down below. Just as a reminder, the links that are in this video will be in the description below as well. Have a good one.